Hello everyone, welcome to TechnoGATE. So my name is Brij Kishore. So in the today's session we are going to start analog electronics. So first of all we will see the syllabus of this subject and we will start with from very basic understanding. Okay, so this subject is completely dedicated for the electronics branch and for the electrical engineering branch. So let's begin our discussion with the syllabus. So this is the syllabus which I have written here. Mainly chapter name I have mentioned here. Each and every chapter we will discuss completely in the detailed manner. Okay, so don't be worried about. I have just written here the name of chapters. So the very first chapter that we will start as per our syllabus is basics of diode. In the basics of diode, we will cover the basic structure of diode, its fundamental properties. Definitely we will go in the brief way. If the subject is electronic devices, then we must have to go in the detail. But the subject name is analog electronics. So obviously we will just understand the basics of diode so that we can understand the application of diode. Because as per the syllabus, application of the diode is a part of syllabus. Basics of diode to just understand the application of diode. Okay. After that we will discuss the BJT. So I'll first of all start with fundamental of the BJT structure and briefly its working principle, and kindly definitely will switch to the main topic, that is a BJT biasing. Okay. After that we'll talk about the BJT amplifier. So in the BJT amplifier, for electrical engineering part only medium frequency analysis is there, and for electronics part medium frequency analysis, high frequency analysis and low frequency analysis is there. So we will deal in the according manner for the particular branch section. Okay, so before starting any topic, I'll mention the branch name so that you will be able to identify whether this topic is valid for your branch or not. After that, we will talk about the metal oxide semiconductor field effect transistor, its biasing, of course its structure, its current voltage relation and basic principal idea. Then we will begin with MOSFET biasing. After that we will talk about MOSFET amplifier, feedback amplifier. After that the next separate chapter. Then basics of operational amplifier. Okay, basics of op-amp. And after that we'll talk about application of operational amplifier, application of op-amp. And the last topic is oscillators. And the last one, after completion of all these topics, the last one topic, that is miscellaneous topics. Miscellaneous topics is a section in which we consider some special topics branch wise. Okay, so in the particular branch like multi-stage amplifier is a part of electronics engineering, and so many other types of topics, those we are going to cover in the miscellaneous topics section. So this is the syllabus, you may write it down. This syllabus is according to the branch electronics and electrical engineering, of course. So let me mention some more points. If we talk about the important topics as per the electronics or electrical point of view, then I must say the very important topic is application of op-amp. Applications of op-amp is a very important topic for the electronics as well as electrical branch. And second important topic is applications of diode. For the EE student, these two topics are highly recommended. Okay, for the EE student, those who are studying very selectively this subject, these two chapters are very important for you. You must have to cover them. Okay, but for electronics students, the MOSFET is also one of the important section, including the chapter 2, chapter 5, chapter 9. These three chapters are very important for the electronics engineering branch, which means in electronics engineering this subject is to be asked about of 10 marks. So out of the 10 marks, about 6 to 7 marks section will be definitely covered by these three chapters. Okay, remaining 3 to 4 marks paper will be comes under this entire section. So I'll discuss each and every topic in the proper detail. So don't be worried about it, whether the important topic will be covered or less important topic will be less covered. No, I'll complete each and every topic in proper detail. But it's our duty or it's our responsibility to analyze the previous papers. On that basis, we can plan our study. So that I must have to tell the which one topics are very important, which one are less important. This is the generally query of the students. So that I have cleared. So these 3 chapters are very, very important, and definitely questions may ask from other chapter also. This doesn't mean BJT will not be asked in the paper. They may ask BJT also, especially in the electronics. They may definitely ask. Okay. So write down these syllabus. Now let me talk very briefly about the preparation strategy, how you should prepare this subject. So in the preparation strategy, so first of all, you must have to be prepared with class notes. Attend all the lectures. Okay, attend all the lectures and form the notes during the lectures. Attend the lectures completely, and during the lectures, please be seated with pen and paper and write each and every point which I'm going to mark on the board. And even I'm just saying, not writing on the board. You must write if it is important for you. If you feel that you don't know about it, then you should definitely write that topic. Okay, so class notes is the first priority. The first of all, you must have to go through the class notes. Okay, second thing what you have to do. Second thing is a GATE previous year's paper of your stream. If your stream is electronics branch, then you must first of all go with the electronics engineering paper. And if your branch is electrical engineering, then you must go with the electrical engineering papers first. Okay, so your own branch. So I'll write here EC plus EE, but what I'm saying, listen to that also. I'm saying if your branch is electrical, then you must solve electrical engineering paper first, then you should go for the electronics paper. Okay, if your branch is electronics, then you must solve electronics paper first, then you should go for the electrical paper. There is a slight difference in the question paper pattern and also the syllabus. So if you are dealing with other branch previous year's paper, particularly if you are an EC student and you are dealing with the electrical paper, then you must have to be very curious about your syllabus exactly. Especially electronics students has no such problem because all the topics of EE are almost in the electronics paper. But EE student has to be must take care of it, because all the part of EE syllabus, all the sections of EE syllabus are not the part, all the syllabus of electronics paper, not the part of EE paper, which means electronics has more syllabus, more chapters, but EE has less. So while solving the electronics paper, EE student has to be take care of whether the topic is the part of their syllabus or not. Okay, and the third one branch that is also important here, instrumentation engineering, the one of the branch in which analog electronics subject is common. So if you have solved these 2 branches questions, then you may also switch to the other branch, that is instrumentation engineering GATE papers, for the practice purpose. This is the second thing that you have to do immediately after attending the class notes, after attending the lectures. Even though in the lectures I'll cover previous year's question, but of course, you know, all the previous year's questions will not be solved in the class, definitely will not be. I'll solve only the questions, those are having twist, those are having better conceptual understanding, those are required for the conceptual build-up. I'll solve only those questions. I'll not cover the questions. Those are very simple, directly based on the theoretical concepts. So those questions you should try by your own level. So when you attend the classes, you will cover most of the very good questions, but for the practice point of view, you must have to be solved the previous year's GATE questions. I'm saying this point repeatedly because I know students generally left that section and go for the other book, ye book, wo book, but we don't require that. We must have to go with the previous year question first after attending the classes. The third thing that you should do, you may appear in the online test if it is available for you, otherwise offline test, whatever the facility that you are having. Okay, so go with the test, and if required at last, you may go with the previous years of engineering services objective section only objective section of course electronics branch and electrical branch. After doing these 3 things, if you still have the time, then you may go for that 4th section. Otherwise, it is not required at all. Okay, so this is a strategy, and that was the syllabus we have till now. Now let's begin our discussion. Now we are entering into the subject. So let me start with some basic fundamentals, basic definition. Then we will enter into the basics of diode. After that, we will go for the application part of the diode. Okay, so these two, initially, those I'm starting now, topics are important as per the understanding point of view. Okay, to understand the subject, to get the feel of subject. Okay, so let's start a discussion with some basic definitions. And I hope you all are very much clear about this definition, but just I'm explaining for my satisfaction. Okay, so let's write the very first definition, and maybe you are not aware of that. Don't worry, I'm here to explain each and everything. So write the heading electronic device. What is electronic device? What is electronic device? A device made from semiconductor material is called electronic device, which means a device which has controlled flow of electron is called electronic device. So what we will write? A device made from semiconductor material. Made from semiconductor material, or a device has controlled flow of electron is called electronic device. That is called electronic device. For example, transistor. We will discuss this in detail in the upcoming syllabus. Diode, thyristors, all these are the examples of electronic device. A device which is made from the semiconductor material. Semiconductor material means, of course, silicon, germanium, gallium arsenide. All these are the semiconductor material. Okay, so next definition is electronic circuit. What is electronic circuit? These are very basic definition. I'm just giving you for your better feeling of the subject. Okay, so what is electronic circuit? A circuit which consisting at least one electronic device. At least one electronic device as a main component. Such circuits are called electronic circuit. What we will write now? A circuit which consists of at least one electronic device. What is electronic device? A device made from semiconductor material, which means a circuit which consisting of a semiconductor material device is called electronic circuit. Okay, as a main component is called electronic device as a main component is called electronic circuit. What it is called? Electronic circuit. A circuit which consists of at least one electronic device as a main component is called electronic circuit. So what are the examples of electronic circuits? Think about it. Amplifier is example of electronic circuit. That is consisting transistor. We are having resistors, we are having capacitor, we are giving input, generating output. So amplifier is example of electronic circuit. Okay. Rectifier is example of electronic circuit. Later on we are going to discuss each and every topic in the detail. So don't worry. Just write the examples here. Write the example. Amplifier. Guys, amplifier is example of electronic circuit. Rectifier is example of electronic circuit, and so on. If we talk about the types of electronic circuit, what are the various types of electronic circuit existing in the world? So the electronic circuits are mainly classified into three categories. First, note it down. Immediately pause the screen right now and just note each and everything which I have written over the board. Just note it down. Now I'm going to scrolling first. So there are three categories of electronic circuit existing in the world. The first is analog circuit. The second is digital circuit. And the third one is mixed signal circuit. Mixed signal circuit. Okay, note it down. Note analog circuit, digital circuit, mixed signal circuit. Note each and every point. Okay, so what is analog circuit? A circuit which can process analog signal, which means a circuit whose input is analog signal and whose output is analog signal is called analog circuit. You may write it this point. I'm just simply writing the one line, analog signal. What you will write? You may write it, first point right here. A circuit which can process analog signal, or a circuit whose input and output in the form of analog signals is called analog circuit. The next one is what? Digital circuit. A circuit which processes digital signals, or a circuit whose input and output are digital signals are called digital circuits. Clear? Now let's talk about the last one, mixed signal circuit. What is mixed signal circuit? A circuit which can simultaneously operate on analog signals and digital signals. A circuit which can operate simultaneously on analog signals and digital signals are called mixed signal circuit. Okay, these definitions are very much clear to you. Now let's go for the next thing. Okay, so if you want to know what are the examples of these circuits, so analog circuits, this is the entire subject currently that we are studying. It's all about the analog circuits. Okay, so this subject is completely dedicated for the analog circuits. We will discuss the entire devices under the analog circuit. Okay, so now onwards we are starting it. This is the subject which you have studied separately, digital electronics, okay, by name, and where we see multiplexer, counter, demultiplexer, decoder, half adder, full adder. All these are the examples of digital circuits. Now come to that mixed signal circuit. The mixed signal circuits where analog signals and digital signals operates simultaneously. So of course the examples of mixed signal circuit is, what are the examples of mixed signal circuit? Mixed signal circuits examples are analog to digital converter, ADC is the example. Digital to analog converter, DAC is the example of mixed signal circuit. Okay, so hopefully you have understand all this. Now we are starting with basic terminology of this subject. So note it down. Now let's write the next heading. Semiconductor. This is the journey of this subject that we have begun now. Semiconductor. If we say solid on the basis of their conductivity, or another words I must say, their response over the flow of current. Suppose we have applied some voltage across their terminal, then how the solid is responding on that applied voltage. On that basis, we classified the solids into the various categories. We say the material is insulator if there is no charge carriers. That means there is no current flow. Okay. If there is a very significant conductivity is present, which means high amount of current it is able to flow, but it shows very small amount of resistance also, then we say it is a conductor. Okay. If a material that has the current conduction capability which can be controlled, which means its current conduction can be increased or can be decreased. Basically, we can adjust its performance with respect to applied voltage. So we can make it a material which has high resistance providing low current, and we can also make it a material having low resistance and providing high current. Okay, and we can also make it a moderate element which can moderately allow the flow of current and offers a decent resistance, which means we can control the conductivity of the material. That wonderful material is semiconductor. Okay, semiconductor is a very, very important material of the electronics industry. So we are the electronics engineer. So this is the big thing for the electronics engineers. So to understand the semiconductor physics. But the semiconductor physics is apart from it. We are not here to deal with it. But in analog electronics, you must have a feeling why we are dealing with the semiconductor, why we are starting our discussion with the semiconductor, because it is very important to know. Okay, semiconductor is a material, is a wonderful material in which we can control the conductivity. Observe this. Insulator is something like that which never conducts the current, which means it's useless for the purpose of conduction of current. Okay, and when we say conductor, that's completely having a very high current capability, so it can be utilized in a different way, wiring of the houses and all other things, because it has high current conduction capability and offers low resistance. But the things that can work intellectually is the thing that can be controlled. So semiconductor is a material whose conductivity can be controlled. Clear? So it is a material whose conductivity can be controlled. So semiconductor are classified under the various categories. Semiconductor that we can classify under the various categories. The one is intrinsic semiconductor. What is intrinsic semiconductor? And guys, other is extrinsic semiconductor. So there is nothing like pure material in the real world. Okay, so we are living in the world of humans, so obviously there is nothing like a pure. So we consider for a purpose this intrinsic semiconductor is a pure semiconductor. If someone is asking personally to you whether this intrinsic semiconductor is pure semiconductor or not, you will say no, this is not a pure semiconductor. But for the purpose of our device designing and all other electronic needs, we can purify it and make it 99 and even more than it pure form, so that we say it is a pure semiconductor. But intrinsic semiconductor, guys, mark my word, is not a pure semiconductor. Okay, so intrinsic semiconductor has definitely some impurity, but we consider it to be pure. Okay, if someone is asking theoretically, then you will say it is a pure semiconductor. Go. Okay, if someone is asking in the practical sense, then you must say intrinsic semiconductor is not pure semiconductor. It has some impurity, definitely. Okay, so intrinsic semiconductor, we say it is pure silicon and germanium. Okay, by controlling our emotion, I'm just saying it is pure semiconductor, pure silicon and pure germanium is the intrinsic semiconductor. And when we say extrinsic semiconductor is the semiconductor which is formed by adding some impurity into the pure semiconductor. When we add some impurity into the pure semiconductor, that becomes a extrinsic semiconductor. Okay, so extrinsic semiconductor majorly classified under various category, but here we will mainly deal with two types, the N type and P type. Guys, extrinsic semiconductor is formed by adding some impurity, so we also say extrinsic semiconductor is impure semiconductor. What we will say, this is impure semiconductor. Something which is not pure, we say impure. Okay, impure semiconductor. This semiconductor become impure by adding some impurity. So we also say this is what we say, by adding some impurity we have formed it. So we say it is doped semiconductor by doing some kind of doping. So we also say this is doped semiconductor. Extrinsic semiconductor name is impure semiconductor, and it is also known as doped semiconductor. Okay, so N-type semiconductor. What is N-type semiconductor? N stands for the negative and P stands for the positive. N-type semiconductor is a semiconductor in which negative charge carriers are majority. which means electrons are the majority, okay, and other type of charge carriers is the hole, which is in minority. P stands for the positive, that holes are the positive charge carriers, so holes are in the majority in p-type semiconductor. So P stands for the positive, and holes are the majority here and electrons are the minority here. So let me briefly write some points about intrinsic, about some points n-type and p-type. So we are just going in the brief manner. Okay, this is not electronic devices subject, this is analog electronic subject. I'm just giving all these ideas to you for a feeling of subject, to enter into the application part in a smooth way. Okay, when I will enter into the application part directly, that may confuse to you. Okay, what's exactly happening. To give you an idea how the electronic devices work, then we will enter into the application part directly. Application part is analog electronics. Of course, I will deal with analog electronics, but here just to give a basic understanding. Okay, we are discussing all this. So let's write intrinsic semiconductor. Make a heading here. Make a heading, intrinsic semiconductor. What is the heading? Heading is intrinsic semiconductor. Say what? Intrinsic semiconductor. Intrinsic semiconductor. Let's understand it. As I have mentioned, pure silicon, pure germanium is the intrinsic semiconductor. Semiconductor material is tetravalent. What is the meaning of tetravalent? Tetravalent means an atom is occupied with 4 nearby atoms. Suppose if I'm saying germanium and silicon is the intrinsic semiconductor, suppose I have taken here a silicon, this is a silicon atom, and this is the next silicon atom, this is the next silicon atom, this is the next silicon atom. Silicon atom has 4 valency. Valency means outermost cells electron, outermost electron, or we say valence electron. It has 4 valence electron. So obviously the neighborhood silicon will also have the 4 valence electron, like this. I'm just drawing it roughly for your understanding purpose. So every silicon atom, I'm just showing here the only atoms, those are valence electrons. Okay, though I'm just showing only the electron, those are the valence electrons. We are not considering the inner cells electrons. Actually silicon has a 14 electrons, but we are writing here only the 4. That means these are the valence electron. So one silicon atom is sharing its energy with the other silicon atom, the nearby silicon atom, that's called covalent bond. So this is the silicon atom. Suppose if I'm focusing on the center silicon atom, obviously every silicon atom has forming the 4 covalent bond with nearby silicon atoms. But if we focus on that centered silicon atom, then we can clearly understand this is the structure of silicon. So where one silicon atom is there, and one silicon atom is there, one silicon atom is there, one silicon atom is there, one silicon atom is there. Similar structure with that nearby silicon atom, one silicon atom is there, one is there, one is there, one is there. Just go into the imagination and you will feel there is a tetravalent structure is formed. Here I'm just drawing the 2D structure. Obviously on the board I must have to write 2D structure. So this is the 2D structure. Once you will understand it's a 3D geometry, then you will feel in 3D this kind of a structure, tetravalent structure, has been formed by the silicon. At 0 degree Kelvin, if you feel some points are very important for you, you may write them, okay? Even if I'm not writing on the board. Everything is a theoretical section. I'll deal major points by simply speaking, and some of the point I'll write on the board. So if you feel these points are important for your understanding purpose, then you must definitely write them. Okay, pause the screen right now. Recording is there, na? It's a benefit of recording. Just pause the screen right now and write down everything what you want. Okay, so what I said semiconductor is a tetravalent. You may write if you want. Okay, semiconductor is a tetravalent, and every silicon atom is forming covalent bond with the nearby silicon atoms. Yeah, or I must say in proper word, every silicon atom is forming covalent bond with 4 nearby silicon atoms. 4 nearby silicon atoms are participating in the covalent bond formation with that centered silicon atom. Clear? For this silicon atom, obviously other 4 silicon atoms are forming. For that, definitely other silicon atoms are forming. For that, other silicon atoms are forming. At 0 degree Kelvin, all the valence electrons are participating in the covalent bond formation. All the valence electrons are participating, which means no electron is free. Current conduction will be possible if free electrons are there, charge carriers are there. In the solid, free electrons are participate in the conduction of current. So free electron must be there. But 0 degree Kelvin, all the silicon atom are participating in the covalent bond formation. So there is no free electron. Write a point if you want. Write a point. I'm going to dictate you that point. At 0 degree Kelvin, all silicon atoms participate in the covalent bond formation with nearby silicon atom. Hence, there is no charge carriers in the 0 degree Kelvin. Hence, even if supply is connected across the terminal of semiconductor, there is no current flow in the semiconductor. Okay. So 0 degree Kelvin, I have also written that structure. You may see every silicon atom, or you may say it is germanium. Both the things are same, silicon or germanium. It's a pure semiconductor. Okay, and this is how every silicon atom is forming covalent bond with the nearby silicon atom. You may see here that silicon atom, this is a +4 is indicating silicon or germanium. Okay, so this is forming covalent bond with that, with that, with that, or with this. Participating covalent bond formation, 0 degree Kelvin. There is no charge carriers, which means there is no current flow. Now, what will happen if we increase the temperature? Temperature increment is what? We are providing energy. We are increasing temperature, which means we are providing energy. What energy will do? Energy will be transferred to the silicon. Every silicon atom will get the energy. Once the silicon atom will get the energy, its covalent bond start breaking. Listen, temperature increases, thermal energy will be provided. That energy will receive by the silicon atom, covalent bond start breaking. Once the covalent bond will be broken, what will happen? That covalent bond will move away from this covalent bond. That electron will move away and reaches into the free spacing. And what is free spacing? The space which is available between atom is called free space. This is called free spacing. So that electron will enter into the free spacing. Dosto, this electron is called free electron. Guys, dhyan dijiye. Just be focused on it. These electrons are called free electron. What are these electrons? These electrons are called free electron. And the vacancy created by that electron, because electron will move away from this covalent bond, so obviously the vacancy is created, or we say this is incomplete covalent bond. Incomplete covalent bond. Incomplete covalent bond. Before that electron move from that covalent bond, there was an electron and covalent bond was complete. Okay, once that electron will move away from that covalent bond, definitely there is a vacancy. This vacancy is called incomplete covalent bond. And guys, this incomplete covalent bond also termed as hole. Okay, what exactly happens after increasing the temperature? Let me observe it again for you. Give your concentration on it. Let's see. We increase temperature, provided energy, covalent bond will be broken. Covalent bond will be broken. Electron will move into the free spacing, that is called a free electron. Free electrons is created. Okay, and that created free electron, here the free electron is created and the incomplete covalent bond is there. That incomplete covalent bond is called holes, which means the covalent bond was broken. Two things is created. The one is free electron, other is hole. Hole is nothing. This is the incomplete covalent bond. The incomplete covalent bond is being termed as a hole. Got it? Up to that point, there is no confusion at all. Now, listen to me carefully. Suppose in this condition, if I'm going to connect a supply across its terminal, let's see. Just to understand, we are here for the competitive exam, so obviously we will mainly focus over the understanding. Let's see. Suppose I have connected a supply across its terminal. What will happen? This negative supply will repel the electrons. So these electrons will start moving. Only that covalent bond is not broken. Now, other covalent bond is also broken. So obviously there is a bunch of free electrons created. So these free electrons will start moving from negative to positive terminal of the supply. Okay. Now listen, one more point. This incomplete covalent bond is there. Okay. This incomplete covalent bond is there. So obviously any one of the electron from the covalent bond, suppose from that covalent bond, electron will move into this incomplete covalent bond. The nearby covalent bond electrons may also switch into the incomplete covalent bond. Listen my every word very carefully. If you feel this is new word for you, just you may write it. Okay. So I'll explain each and everything. This is a theoretical section. I'm not going to write everything here, but I'll explain each and every point so that you will get correct idea about the semiconductor. Okay. So let's see. So this electron, this covalent bond electron will move into that hole. So that hole become complete. Now here a whole vacancy will be created. So indirectly what we say that hole move into that place to this place. Basically exactly what is happening, this electron move into that incomplete covalent bond. So that hole is created here and that incomplete covalent bond get filled. This is exactly happening. But what we are interpreting that hole move into that side. So we say when supply is connected, holes will move into positive to negative terminal. Hole start moving from positive to negative terminals. Electrons start from moving from negative to positive terminal. So here movement of holes up. Now write down the point which I am saying. Movement of holes from positive terminal to negative terminals causes holes current in the semiconductor. Next point. Right, the next point, movement of free electrons from negative terminal to positive terminals causes the free electron current. Hence, electron moving from negative to positive, so the current which is causes by the electron, I'm speaking speedily, but you may write by pausing the screen, okay, according to your convenience. So, flowing electron from negative to positive will causes the current from positive to negative. The conventional direction of current is positive to negative. So I'll say in the semiconductor, total current is what? The current which is caused by the hole plus the current which is caused by the electron. This is a total current of semiconductor. Actually, the whole current is positive to negative, but electrons are moving from negative to positive, but they will also contribute the current in positive to negative direction. So whole current and electron current both are the same direction current. Clear? So in the today's class we made the discussion over the intrinsic semiconductor. In the next class I'll make the explanation about n-type and p-type, and we will also talk about some more important node points. Okay, so that will be enough for this class. Thank you.